maximum to the minimum, the ratio between the maximum by minimum, the number, the roots, the value. So if that is much greater than 1, then we consider that problem to be a very steep. Though it is a relatively, or whether 10 is much greater than 1 or 10,000, that is we have to consider. But of course, 10,000 is much more, so we can consider that more or less it is accepted that if it is of the order of 10,000 or 1 million, this ratio, this value of S, then we consider that is a very stiff problem. Now there are different integration methods or solver that we have in our MATLAB thing, but also available a numerical subroutine that is used for what is called calculation of this kind of steep differential equations. So basically we are aware of different explicit routine, the numerical integration technique, for example, Euler method, and basically the RK method, the Runge-Kutta method, which is also based on explicit Euler. So that actually sometimes fails. So that fails, and that means it may provide some solutions, but extremely slow process. That means it will take long enough time to give you the solutions. So what is also sometimes it's basically stiffness is can be also looked at as it is an efficiency issues. That means whether a problem can be solved or not, depending on the efficiency in terms of time it actually takes. That means computational cost. So some non-stiff method, now non-stiff, so basically there are two angles. One is the problem specific and one is the solve or method specific. Now there are some stiff solver or there are non-stiff solver, and there are some problems which are basically stiff and non-stiff. Now problem specific, you can actually check the stiffness number, right? Based on the stiffness number, you can actually you can actually call that the problem is a stiff problem or a non-stiff problem. And there are actually some solver based on explicit method or implicit method, for example Geer's method or Adams-Moulton method, which are based on backward Euler method. Those are implicit method. So based on that you can you actually are able to overcome the problem of steep differential equation. So MATLAB has both category of solver. So basically non-steep method is often called as this kind of ODE45 or the explicit Euler based method. So they are able to solve, but sometimes they will take extremely long time, right? To extremely long time to provide a solutions, or they may provide a inaccurate solutions. Or even fail to provide any solution at all. So that means if the solver is based on the non-stiff solver, or if the solver is happen to be a non-stiff solver, that may or may not solve a stiff problem, right? But if it is so that's why a specific methods or integration routine or solver is required which can exclusively tackle a stiff problem. And since we call it as an efficiency issue, that means it will accurately able to deal the stiff problem, and it will not computationally will be costly. I mean, it will give the results in a much lesser time, and the solution will be accurate, or the solution will be accepted. It will not that it will be inaccurate or it will not provide any solutions, right? So these are some introductory statement and concepts that I was thinking that let us introduce in this manner. And then from this point onward, we will start tomorrow to first look at an example from a just mathematical side, and then we will go to the transient CSTR, where we will actually see that how this is actually varying. And if we take a non-stiff method, then what will happen? Then if we take a stiff method, that means if we take a non-stiff solver, then what will happen? And then what benefit we will get if we take a stiff solver, that means specific to tackle the stiff differential equations or stiff ODE. And finally, we will end with the limit cycle operations or conditions where we will see that there is a operational situation where there is no steady point or steady operation is not there. It will just revolve around the cyclical manner. So this will be the agenda in the next class, and yes, I think that is the next class agenda, and today we will stop here. Okay, so thank you all. We meet again next day for the class. Thank you, Deepak and Rushikesh and Sunil. We meet tomorrow. Sunil, we will talk sometime. I will call you maybe after tomorrow. Okay.
Okay, sir.